Hello everyone, welcome on the sessions on the solution of NAT Mathematics PYQ. So this is a question which is based on the concept of like idempotent matrix. We can say idempotent matrix. What it is given, let us try to read it, then we'll proceed for the solution. It is given A is some matrix which is not equals to IN. I stand for identity matrix, such that A square equals to A and IN stand for identity matrix of order n. Then which of them are false? They are talking about the false statement. So when it is written that A square equals to A, we comes across to know that this is a matrix known as idempotent matrix. A matrix which is such that A square equals to A is called as idempotent matrix, and as a result we know that the eigenvalues of an idempotent matrix is what? Either 0 or 1. How? We can write it as A square equals to A square minus A equal to 0, which gives us, if I put A equals to lambda on it, where lambda stands for eigenvalue. So lambda square minus lambda equals to 0. And this is how I comes to know that eigenvalues of such matrix are 0 or 1. So over here we conclude one thing, that the eigenvalues of this idempotent matrix is either 0 or 1. Okay, now let us check the options. So option number 1, it says that identity minus A square equals to identity minus A. That means if you see it critically, they are saying that IN minus A is also idempotent matrix. So let us try to solve this. So IN minus A whole square, open the square, identity square minus plus square of the matrix minus 2 identity into A, opening the whole square. Since A is idempotent matrix, so A square will be replaced by A. Identity square is itself identity. Identity into matrix is that matrix. So what I get it as IN, then A minus 2A is A. So what I obtained, IN minus A square equals to IN minus A square, which is same as the definition of idempotent matrix. So yes, I can say IN minus A square equals to IN minus A. So the first option is the correct option. Here we are supposed to find the false option. Okay, so this is correct, true. Now, they are in the second option, they are talking about trace of A equal to rank of A. Trace of the matrix A is equals to rank of the matrix A. As a result, we know that the trace of the matrix is what? Sum of eigenvalues. In our case, sum of all those eigenvalues, which is 1. Sum of all those eigenvalues, which is 1. And hence, we can say that if a matrix is having, let it be 3 by 3 matrix, and its 2 eigenvalue is 1 and let it be third is 0, so the matrix can be written like this. Okay, so it is having 2 eigenvalues as 1, and so the trace of this matrix is how much? 2. Also the rank of this matrix is true. We can also say that for an idempotent matrix, trace is always equals to rank. Okay, because when you know the eigenvalues of matrix, we can write in terms of a diagonalizable matrix, where we can put all the eigenvalues of the matrix on the diagonal. So second also comes out as true. Talking about option number 3, rank of A plus rank of IN minus A is n. Rank of A, as we know that the number of eigenvalues as is 1. Number of eigenvalues as 1. Rank of IN minus A. IN minus A is also idempotent matrix. IN minus A is also idempotent matrix. So if A is, if suppose that this is the structure of A, and if I find I minus A in this case, how much it comes out as? So those eigenvalues which are 1 converted in 0, and those which is 0 converted into 1. So this is how it looks like, I minus A. Understood? So the rank of this matrix is how much? It is 1. The rank of this matrix is how much? It is 2. And their sum will be how much? 2 plus 1 is 3, which is same as n. So the third option is also true. Even though without checking option number D, we can say it is correct, because out of 4, only 1 need to be correct. But still, let us go through with it. The eigenvalues of A are each equal to 1. And as a result, we know that the eigenvalues of an idempotent matrix is either 1 or 0. So this option is false. Hence, the right option for this problem is option number 4. Even though without checking the first 3 options, we can directly jump to option number 4 and find that this is the incorrect option. Hence, this is the true option for this problem, because they are asking for the false statement. Okay, so I hope you understand the concept for this problem.